And then we're going to share part 4 briefly with each other, because I know that I gave you more time I wanted to do on that part, and that's okay. I think that I heard some great conversations, and then I'm going to take up the little periodic table that you were working on. So write your group names on that, okay? The small periodic table you're writing your answers on, write your group names on that. And then what I'll do is I'll give you feedback and let you finish that later, but I want to see where we've gotten so far. If you didn't finish, don't stress. Okay, eyes up here. You got a periodic table to draw on? All right, we came to some conclusions already about how the trends work. I'm going to briefly explain this one more time, and then you guys are going to, we're going to share part 4, and then you're going to watch a video on the trends so that you have the details of why the trends occur. So we wrote the atomic radius going down, up group, and across the period, right? Those were that's the atomic radius trend. So can I just assume that you know that my arrow is pointing that way, and that way the arrows mean increasing? Okay, arrow means increasing. So this is atomic radius. Okay, how do all the other ones trend? Yeah. The atomic radius increases down a group, and it increases from right to left across a period. Okay, how does everything else trend? They happen to actually trend the exact same directions. So going across from left to right, what happens to ionization, electron affinity, and electronegativity? Increases. Okay, so guys, we are memorizing the trends, reasoning why they work, the background behind them, and then the directions at which they increase. So you guys said from left to right, ionization energy, electronegativity, and electron affinity generally. I know the electron affinity one had some weirdos, exceptions to the trend, but generally they all increase from left to right. Okay, how do each of those 3 trends increase or decrease on a group? This is on your part 2. Top to bottom, they increased or decreased? Can we double check? Anybody? They decrease, right? So I'm instead going to write it as an increasing nature. So EJ said it decreases down a group. So how does it increase? Up a group. All right. All these down here, ionization, electronegativity, and electron affinity, all increase up a group. All right, drop pencils, do this for me. I'm going to show you how to memorize this, guys. I did this in whatever grade I took chemistry, so I could remember it for life. All right, hold up your right hand like this. So it's like a little axes, right, like I have here. Right hand, you got your right hand? Turn it to the side like this. Right hand represents the radius. It increases where your fingers are pointing. Make a little picture. Can you make a picture? What's your so your right hand is pointing towards the left, your left hand is pointing towards the right. Look at this nice little picture, right? Okay, so right hand represents radius, what's your left hand represent? Everything else. If I want to see you doing this whenever you think, okay, right hand radius increases to the left and increases down. Everything else increases up, increases to the right. Yeah. Ionization energy, electron negativity, and electron affinity. These are the definitions you took down and we're reading at 6. And also, you're going to see a little bit more of those on your notes today. Okay, so if I took this away, can you tell me who's bigger, carbon or nitrogen? Who's bigger, meaning atomic radius? Carbon is bigger because it's farther to the left on your hand, right? Okay, who has a higher ionization energy, magnesium or calcium? And which hand is that? Left hand. Magnesium is higher than calcium, or has a higher ionization energy. So this is just using the trends, just knowing the directions they go, and identifying bigger or smaller things, right? But we're going to learn a bit more about why they exist. But before we do that, I'm going to do a quick informal share-a-thon because we're running a little bit behind. So I have you 2 groups, you 2 groups, and you 3 groups are going to share about your question 4 that you selected for homework. And I'm going to put the timer on for about 8 minutes. That means 4-ish minutes each, a couple minutes less than that. You're just going to share what you found out through your research. You're going to make sure it's shared with me, okay? Whatever you found, just share it with me. So if you need to spread out, spread out. I'm going to give you a minute to get started. All right, so you guys get on. If you need your laptops for your laptops, but you're sharing with your
I know, I just said if anything's wrong. Guys, we got it. What? All of a sudden. Well, you technically type in everybody else.
You guys are going to be in one big group. Yeah, share with me, like, electronically, and then share verbally with your family. Oh, okay.
Not ready for the call.
So this big group, get together, let's go. This big group, what are we sharing?
Sharing their
So who can see that? Are you going to take a computer?
I mean, should we?
No, I think it's better for verbally share. So if you need to show them anything, show them, but that's just a typed out version.
So.
Eventually we will run out of raw materials, or it'll take a while to replenish. And a lot of times I'm just have the
Every material is obviously not because energy sources such as fossil fuels. And they're not replaceable because we use them faster
what types of materials are most important for recycling, whether recycling materials are nationwide law. Well, said a couple things in one, because making aluminum cans for recycled aluminum rather than new aluminum takes 95% less energy to produce, especially based on the recycling aluminum could save a lot of energy. And also recycling paper, we hope to reduce the number of trees that cut down, and plus the amount of energy used paper, as well as reduces the solid waste that we add to the waste stream. On average, American uses over 700 pounds of paper a year, so we just started recycling every some back and we should know paper that we have. Should recycling be made international law? Recycling should be made international law because it's not outside that side.
Very, very
It's also fairly commonplace, so it really wouldn't be that hard to make a law for recycling. And the extent of enforcement of the law justified, you have to recycle within the law, plus the savings.
I don't know. I'll look in a second.
Can be more considerate to recycling. The toilet paper itself is questionable.
Are you guys done sharing? Yes. I guess what's next?
My test.
No, it's just you can give me your test back. You were good. Just I'll fix it. My grade.
That's fine. I'll get it to you.
Thank you. So sorry about that.